4.3 Evaluating Definite Integrals. Number 9 says use the evaluation theorem to decide if the definite integral exists and either evaluate the integral or enter dne if it does not exist. And so we're given the integral from 3 pi divided by 2 to 4 pi of secant x tangent x dx. And so we have to try to find the antiderivative of secant x tangent x. And so we're thinking to ourselves, when we take the derivative of some function, we get secant x tangent x. Well, the derivative of secant x is secant x tangent x. And so this is our antiderivative. So we're evaluating now. We're evaluating the antiderivative secant x from 3 pi over 2 to 4 pi. Well, I personally do not have secant memorized, so but I do know this identity. 1 over secant theta is equal to cosine theta, or 1 over cosine theta is equal to secant theta. And so I can just replace that. So once I evaluate, so this is the same as upper limit minus lower limit, so secant of 4 pi minus secant of 3 pi over 2. And we can use this identity. So I'll rewrite secant of 4 pi as 1 over cosine of 4 pi. And then subtract 1 over cosine of 3 pi over 2. Cosine of an even number pi is a positive 1. So cosine of 0 pi is 1. Cosine of 2 pi is 1. Cosine of 4 pi is 1. So this is 1 divided by 1, or just 1. And then we're subtracting. Well, cosine of 3 pi over 2, if we're looking at this visually, our cosine values are the x, and our y values are our sine values. Cosine of 3 pi over 2, this is 0 pi. This is pi over 2. This is pi. This is 3 pi over 2. Observe, if this is 3 pi over 2, x is 0 for all of these numbers. And so cosine of 3 pi over 2 is 0. Or now we have a 1 over 0. Well, this is undefined. But 1 over 0, as the denominator approaches 0, this whole number approaches infinity. So we have 1 minus infinity, or the limit does not exist. So